I've been asked to give a quick presentation on F#, which is one of the .NET languages that's officially supported by Microsoft. So it sort of falls in the category with Visual Basic and C#. Runs on the .NET runtime, is officially supported in Visual Studio, and they are pushing it reasonably hard. It's been around for a few years now. First version that was included in Visual Studio was actually the version 2 release in 2010, and there's now a version 3 in the latest version of Visual Studio. And the language itself is older than that.
A quick poll.
Yes?
Who's heard of F#?
Who's heard of it? Everyone.
Have you? Who's had a play with it?
Anyone played? Yeah, some of you have played. 6 or so people have played. Okay, fair enough.
Who's done any serious programming in it?
A bit. Language design-wise, it's based heavily on an existing language called OCaml. They've cleaned up the syntax a bit, but it does actually still have a compatibility mode. So you can pretty much take most OCaml code and compile it in F# as a .NET library if you have any reason to. That's probably more of interest if you're doing scientific computing, but hey-ho. What was it built for? In the creator's own words, when he put it together, he wanted something that was robust, efficient, type-safe, succinct, and analytical. The last one being a bit vague and woolly in my mind. I would also go with pragmatic. He has made a lot of decisions that are there basically to keep it as part of the .NET family and make sure you can use it with the other .NET languages easily, that you wouldn't necessarily have otherwise made in a language of this type. So there is kind of a pragmatism element there of it works with the rest of the .NET framework. So how was he trying to achieve this? I've got them all. So we'll go into how he was trying to achieve that in a moment. But it is in use in places already. I completely failed to put the slide in, but I was going to mention it's actually in use quite a lot in a fair number of industry locations at the moment, mostly in finance houses. Apparently Aviva Insurance use it, and a bunch of banks in London that Microsoft aren't allowed to name for various reasons. E.ON use it for doing international energy usage predictions and market predictions. We use it on a much smaller scale. We have a couple of projects that use it. There's a couple of utility projects. There's a little open source NUnit result merger that if you want to just get a feel of what this language looks like, that's actually quite a good place to start because it's very self-contained and it's quite obvious what it's trying to do. And we're also experimenting with something called Fake, which is F# make. It's a set of helper libraries for writing build scripts in F#, mostly because our MS build scripts are incredibly painful to work with and getting somewhat unreliable as they get more complex. So, there you go. We currently don't use it for any of our products code as it stands. What could we use it for in the future if we decide to? What it's really designed for to be its strong points is dealing with continuous streams of data. It's very good at sort of just taking an infinite sequence of data and just waiting for more to come through and then pipelining it through to other places. If you write in a sort of idiomatic F# style, it's very good at writing highly reliable infrastructure pieces. Basically, you choose to take a set of restrictions in exchange for more reliable code without having to think about it as much. It's good at writing highly parallel processing. It's got a lot of helper functions in there, and just the style of writing code in it is helpful for writing parallel working pieces. And I actually find it very good for unit tests, because as we'll see in a moment, especially if you're writing something small and simple and static, it is much more succinct than F#. There's a lot less just kind of boilerplate declaring namespaces and classes and adding curly brackets and all this kind of stuff. So what's the difference from C#? Basically, both of them are multi-purpose languages, so they both cover a range of programming styles. But the real difference is that when you start looking at the syntax, C# tries to make your life easy if you're writing in an object-oriented style, particularly an imperative style. F# tries to make your life easy if you're writing in a more functional style, which leads us into what the heck is the difference. So this is my metaphor for imperative code. You get something, normally a piece of data, and your functions are a bit like tools. You get them and you whack your data with them until it turns into a different shape, which is the shape you want it in at the end of the process. It tends to be quite easy, but it does have a few downsides. One is that once you've started whacking your data with a hammer, you don't have the original data anymore. One is that once you've whacked it once with the hammer, when you whack it a second time, you don't get the same thing again. You get something different. And that basically makes it a bit more opaque what your code is actually doing. And it also can make testing much more awkward when you start getting into sort of what's the actual state when I call this function. Functional programming makes a different set of trade-offs. I'm going to call functional programs factories, basically. They look at a piece of data at one end and they use that as a schema to build a different piece of data at the other end, possibly with some other stuff thrown in the middle. Upsides are, if you give the same piece of data at the beginning to the same function in a functional language, you'll always get the same answer. This can be pretty useful. You always have access to the original data, even after you've mangled it, which can also have some advantages, especially in sort of concurrent or parallel workflows of different kinds. The downside is you can't change your original data. A whole load of the assumptions you're making in your functional program break if you start mutating your input. So you do need to be a bit careful, because otherwise you start losing the advantages. And the other one is that you always end up with copies of your data. Now, F# has a whole bunch of immutable types to help you with that, where if you make a copy, it doesn't actually copy the whole data set. It basically links back to the original and then makes a record of what's changed. So it's not quite as inefficient as it sounds. But you can still end up with issues where functional languages do tend to be heavier on memory usage. So if that sounds strange, it's probably just because you've never heard it named before. You have been doing functional programming already. A lot of it actually exists by default in C#. So string manipulation in C# is always functional in style because strings are immutable. Link expressions are an example of functional programming. I don't know if you've noticed, but each time you chain together your link expressions, you get a new query out of the other end. You don't change the query from the stage before. And pretty much anything with a fluent API, that's basically the easiest way of showing a functional interface in C#. So anything like Rhino or Windsor, just because it's fluent doesn't necessarily mean it's functional, but there's a good chance that if someone's bothered to write a fluent API, it's probably functional. So hopefully you can actually see the code. So what does the syntax look like? So a minimal program. As I was saying, F# doesn't like boilerplate very much when it can avoid it. So the minimal F# program is literally just a output hello world. If you don't give it a namespace, it will assume that you want a namespace named after either the project or the file, depending where you're compiling it from. And basically from a .NET point of view, you can assume that your file is a static class. So just having a file is the equivalent of having declared a namespace and a static class in C#. Does that kind of make any sense? we'll have an example of it later. If you're writing a longer program, you can explicitly mark a function as the entry point into your program, at which point that obviously gets called first by the .NET runtime. If you haven't marked anything as an entry point, it literally just starts at the top of your file and works its way down. Getting slightly more in depth, what happens if you try and do something like load up a web page? So this is where you start seeing a few more of the distances. I mean, a lot of stuff is very similar. You've got open statements, which are exactly the equivalent of using statements in C#. Again, you've got the assumed namespace. You can open any .NET object, CLR object, from any of the .NET libraries. So there we're newing up a web client. That let keyword there is effectively the same as var in C#. Basically, it says that you want to scope a value. They don't like calling them variables in functional programming because most of them you can't change, so they're not terribly variable. So basically, you can declare values that are open in a namespace. In a scope. Function application, we'll get to this in a moment. If you look at the client.openRead, you don't have to wrap your arguments in brackets. And one of the gotchas in F# when you're starting it is that if you put commas in between your values, that actually means something different. That actually declares a tuple in F#, which is a sort of mini struct type object. So if that client.openRead was taking multiple inputs, there'd be space separated rather than comma separated. And then scoping, rather than using the curly brackets, whatever you want to call them in C#, scope is declared by indentation in F#. So again, one of the gotchas is it will complain at you if you use tabs because it always wants spaces. The reason for this is that if you convert between tabs of different sizes and you put a mix of tabs and spaces, you can actually change the syntactic meaning of your code, which is a tad awkward. So that sort of use reader equals new stream reader bit where it's indented there, that would be the equivalent of sort of wrapping that block of code in a set of curly braces, and that's a scope in its own right. So our stream reader, because it's declared with a use rather than a let, that means it will get disposed, same as kind of a using statement in C#, and it's only in scope until for those two lines. So as soon as that reader.read_to_end is finished, that reader will get disposed as it exits the function. We'll come back to match, the match thing in a moment. That's the ignore bit. All right, okay. F# as in a functional language, well, you can see it as well with the reader. Oh no, you can't. There you go. Sorry, ignore that. As a functional language, F# assumes that every expression returns a value. So there's kind of, at the end of a function, if you just have an expression on the last line, it will return that as if you'd used a return statement in C#. It just assumes, hey, you're at the end of a function, here, have a value back. It also complains at you if you do something that returns a value and you don't do anything with it. It doesn't actually throw a compile error, but it does give you a compile warning. So it basically says you're returning a value here, but you're doing nothing with it. Why are you bothering? So because of that, you do have this ignore function, which is basically just a way of telling the compiler, shut up. I don't care what that value is. I am deliberately ignoring it. Please make it go away. And the little operator next to it, the little vertical line with the greater than sign, that's just what's known as a pipe operator. It basically does what you would expect. It takes whatever's on the left of it and feeds it to the function on the right. So, for example, in that console.read at the bottom, if we'd written that the other way around, do I have a cursor? Yeah. If we'd written that the other way around with the ignore at the front, basically ignore is a function that takes one value. So if we tried to just write that the other way around, ignore would have taken the console.read function before it was called, and it tried to ignore it, and then you would have been left over with this, what's called the unit operator here, which is kind of a, I don't care what this value is, but do something. So if we put that the other way around, console.read with the unit would have need to be wrapped in brackets, and you start building up brackets quite quickly. So that pipeline operator is just there to help make your code more readable, basically. So I'm going to split the rest of this into two halves, basically. I've completely stolen a resource from somewhere else for getting to play with F# as a language. So I was going to suggest that we spend half an hour actually just, I'm going to boot you out in pairs to go and pair work your way through the beginnings of the F# koans exercises, just to get a feel for what the language is like. This is kind of just going to be a quick 10-minute overview of features that some of you might recognize from other languages, and sort of enough of a keyword to allow you to look things up if you want to, but I'm not going to actually dwell in any details on how any of these work or what they do. So it's kind of this is why I think F# would be nice to use and open up discussion rather than actually explain everything. So why would you want to use F# over C#? What features does it have that C# doesn't? So it's much better at type inference. C# you can declare a variable with var at the beginning rather than specifying the type, but it's pretty dim about guessing. If you can't work it out from that one line, it will just complain at you, basically. F# you actually get quite a lot of benefit from the fact that it will do things like it will try and infer the types of functions, which is quite useful because it will quite often show you that your logic is wrong. If, for example, you're expecting your function to return a list of things and it's only returning one value, or vice versa, or sort of other things like that. It's actually surprisingly nice at helping catch errors. Despite the fact that it's very rare to see a specific sort of typing added by the programmer in F#, it is statically typed and strongly typed. So you can check at compile time what types will be, and Visual Studio will pop up nice little pop-ups if you hover over a function name and all that kind of stuff. So one thing which is nice about F# is it has this match statement, which is kind of switch on steroids. Basically, it allows you to take in a piece of data and then punt it off to different functions depending on what it is, and you have all kinds of options for doing that. So one nice one is you can do things like maybe values. So instead of getting null values like you would in C#, normally you'd represent that in F# with what's called a discriminated union. So that maybe error there is an example of a discriminated union. Basically, you're saying this is a type that wraps two or more other types. So in this case, that just says, okay, I can have a result of anything or an error of type exception. Does that make any sense? But then what's nice about it, this is where you get back to, again, the type inference working quite nicely. If you call a function that returns a maybe error, then when you get it, like in that handle flaky function example below, you can match on all of the options about which one of those members of the union it is and do something different depending on what it is. And the compiler will warn you if you try and ignore the fact it's a maybe error. So if you call, if someone's decided flaky function is calling out to some ancient legacy system that falls over because, someone's hit it with a broom twice a day or something, so they decide that, they want to flag up the fact that this function frequently returns errors, they can wrap that error in that result, and if you try and just use the result without checking if there's an error, you'll get a compile error. It won't let you do that. You can do pattern matching based on type hierarchy. So basically that, the next one to the right, basically that : is a conditional cast. that basically says, okay, take my argument, see if you can cast it to a string or any subtype. If so, do this. See if you can cast it to an int. Otherwise, that underscore is basically just a catch-all. I want to cover the rest of the sequence off. You can do just sort of fantastic logical switch statements based on the actual value of the value, if that makes any sense. You can effectively have if statements in your match. So you can do different things. You can, it makes it very easy to write guards on functions that, where certain values wouldn't make any logical sense. It makes quite a lot of business logic type directioning much easier to put in. And also, for those of you who've played with functional languages before, you can do list and tuple deconstruction as part of a match. So basically, that first line, that x double colon y, if you feed a list into that function, that will give you in the block that matches with the x double colon y, you'll get a value called x, which is the head of the list, and a value called y, which is any remaining values still as a list. Did that make any sense? I'm sort of aware I kind of skipped through that one. Talking about robustness, F# has a idea of units of measure, so you can declare a number not just as a number, but a number that's measuring a particular type of value, and it will give you compile time warnings if you try and do nonsensical things like, adding speeds to distances or adding, and you also have the choice of if there are things that would have an equivalence relationship like currencies. You can choose whether you actually specify a conversion rate or whether you want a compile error if someone tries to use, dollars as pounds. So, quite often for things like distances, you'll have an automatic conversion that if you feed a distance in inches into a function that expects centimeters, it will just automatically convert. Obviously, when you start getting to things like currencies where the conversion rate fluctuates, it's much more common just to have actually, I'll just throw an error here, your bank account is in pounds and you're trying to add dollars to it without having gone through the appropriate process. Has records. I mentioned these earlier. These are basically, they look a bit like a struct in C#, but it's slightly nicer to work with. They're immutable data structures. You can actually use them from other .NET languages if you have need in C# of a set of immutable classes. Obviously, the fact that they're immutable means that they're fully read-only on creation. F# has a set of helper functions to basically create a copy of a record with one value changed, or with a selection of value changed, as we were saying earlier. They can have methods on them, just like any other .NET class. The F# compiler does support tail call recursion. If you don't know what that is, you probably don't care. If you do, it's actually very useful. It effectively allows you to write infinitely recursive functions without ever blowing the stack, which can be useful. Word of warning, it's turned off by default in debug builds, because what it basically does is at the end of each recursion it throws away the stack. So if you try and debug a piece of code that is recursive and you have tail call recursion turned on, you can't actually tell how many times it's recursed because it throws away the stack each time. So somebody somewhere made the decision to turn it off by default if you do a debug build. There's a whole collection of what it calls computational expressions, what are called in other functional languages monads. They're basically just a way of orchestrating a set of functions, which sounds a bit high level, but examples that are built into the language, seek is actually probably the easiest. Seek is basically just a way of declaring an IEnumerable. So you declare a seek block, you can do things like yield values from it, and everything else in the program will just see them as a lazy IEnumerable list. It's how you access the link language features in F#. You build query expressions. And also kind of what it was famous for in a way, well before sort of tasks and things in C# is it also has a asynchronous workflow syntax built in where you can basically mark pretty much any method you want as an async method and flag the points where you're expecting it to have to wait for a result, and then you can just pass in a whole load of async methods to a async runner, and it will deal with all of the scheduling and how many workers do I want and all the rest of it in the background, as long as your async blocks don't have side effects. So, no shared objects between them. You can also write your own monads. So this is taking that maybe error type from earlier. You can do things like say, well, actually, it would be really useful to have a set of functions where I'm going to do a chain of, I'm going to go through a chain of calculations. If any of them fail, I don't want to bother calculating the rest of them. I just want the whole thing to fall through, but I want to know what the error is at the end. So as you can imagine, you could end up with a sort of nasty wrapping each stage in the calculation with another level of the guard that checks, oh, was that an error or not? You've probably seen it in our code where we have nested levels of try-catch blocks in our C# code. Try-catch this, oh, it's an error I don't know how to deal with, rethrow, it goes up another level, try-catch this and all the rest of it. We probably do too much of that, by the way, but that's an aside. So you can do things like, with computational expressions, basically say, okay, well, I'm going to feed in a bunch of functions, but with that bind method on the left, every time I call one of those functions, I'm going to check whether it's an error or a result. If it's an error, I'm just going to pass the error up the chain. If it's a result, then I'll actually try and apply it to the function and actually try and work out a new value. And there is syntax support for that in F# afterwards. Once you've sort of declared your strategy on the left, on the right, you can do things like that sort of special let with an exclamation mark is basically saying, okay, this is where I want to start kicking in my, I'm not sure what the result of this function is going to be side of things. And then you return a value at the end of your maybe error block. That returned value will be a maybe error. So whatever you're returning it to does have to know how to deal with that. But for example, where in that second block where we've divided by 0 as one of our calculations, what you get out at the end, rather than your program throwing an exception there and then, which especially if you're working on something synchronous or you've punted it off to another machine for sort of a remote operation or something like that, you actually get the error back wrapped up and you can choose to deal with it how you want. You can even at that point just extract it from the maybe error and throw it. Just go, well, hey, actually, I wasn't expecting that one. The process should go down at this point. Those of you who have played with things like Haskell and Scala can probably think of about 500 other examples of monads that it would be nice to have lying around. It has support for agents, for those of you who have played with Erlang. Basically, they're a bit like a thread, but again, in exchange for guaranteeing that your code is isolated and doesn't try and mutate any shared state or anything silly like that, it will give you lots and lots and lots of very lightweight processors with very little overhead and manage them for you. Bizarrely, they're called mailbox processors in the standard library. Turns out, I found out last week that this is because there was actually a team working on agents for C# at the time that the F# library was being put together, but then they never made it into Visual Studio. So now we have mailbox processors in F#. Fortunately, though, like C#, you have access to type abbreviations. In F#, you can rename types within your own code. And as I said, it's a very pragmatic language. It has a lot of stuff in there that you wouldn't expect in a functional language, just to make sure you can interface with all your C# code. So you can define classes, interfaces, you can define extension methods. You do have access to things like for loops and all those other nice imperative things that you've come to expect from a programming language. So there you go. So let's see. I can just very quickly show you some stuff. So I was having a quick play with. You're actually going to see. Thank you. You're actually going to show me anything? Ooh. So that took slightly longer than I expected, so I'm probably not actually going to do any live coding, but just to give you sort of example of the kind of things it's reasonably easy to do. I was having a quick play with EasyNet Q in F#. So this is kind of a sort of minimal EasyNet Q program. This is very much a sort of completely trivial hello world. So you can declare a module that's effectively giving a name to your static class that this file is representing, an open statement. That is how you declare a type of record in F#, those little immutable classes. So that's basically saying, give me an immutable class with a type called a message that has a single property on it, which is a string called message. It's not terribly exciting. Give us a rabbit hutch. And then there's a publish, just a little publish method. We subscribe to it first, and then we publish, and if I hit F5, we should get a... apparently I haven't. Should be. It's a bit weird.
What does the inline keyword mean? What it seems like it means?
No, actually, this probably shouldn't be there either. I suspect I've got conflicts on IP addresses, but... So I might need to give up on this one. I can't even remember what the rabbit... It's that, isn't it? There you go. Go away. No, that's pretty keen. It's already running. Okay, I might need to... let's just try one other thing, and otherwise I'll just skip on to the next bit. Okay, so hopefully that has... There you go. Connected to RabbitMQ, declared a consumer, Rabbit is found the message to be sent, and there's my hello world message that I've sent through. So that's kind of the completely trivial version. And then just to sort of show the kind of thing that features make relatively easy to build up, if we do a git gotta remember what I call things. If we check out my handily prepared listener branch, so if we go a step further and we sort of split it down a bit more how you'd expect in a real program. So we've got our subscriber and our publisher. So if we do rebuild all, let's try it. So this has got slightly more in depth, but not very much. Our publisher in a way has actually got simpler. All we've done is wrapped it in an entry point attribute. The reason for that is that the perceptive among you will have noticed that last time I wasn't disposing of the bus, so the connection just hung around and the program never exited. So got a nice little publisher there.
Is that 0 at the end of your main thing? Is that just to return 0 from main?
Yes. Yeah, that just returns 0 from main, so you get an exit code of 0 from the program. And so this is kind of what agents look like. So basically this is just to show you the kind of thing you can do. So here's a little program that listens and prints messages. So it creates the bus again, subscribes, and it subscribes using this listener.post function here. So this listener is an agent. You declare it by calling the agent.start method, and you feed it an anonymous function, or you can feed it a non-anonymous function if you wish, that has to return an async value because that's what it uses to manage the workflow internally. So basically everything inside this block is considered asynchronous. That let rec keyword there, F-sharp's compiler makes various assumptions about functions depending on whether they can be called recursively or not. So to allow it to do some of the optimizations it does, if you do want to be able to call a function recursively, you have to explicitly mark it as recursive. Otherwise, you get an out-of-scope error if you try and call back into it. I was saying about typing, if you just hover over these, you do get type information. So start has a slightly more horrible type there. So there's an anonymous function. It has a little inner recursive function that returns asyncs, and basically all it does is this let bang here means get to this stage and then give up control of the thread if you don't have a result. So it will get to that stage and it will just say, okay, until this inbox.receive function returns a value, I don't want control. Just let the rest of the program get on with it. Once it's actually received something, it then resumes flow. So here I'm just printing out the message, and then I'm just saying, well, actually, I'm quite happy with that workflow, so just call back into the function recursively. Because that's the last thing, this is where this tail call recursion thing comes in. Because that's the last thing the function does, and it doesn't keep any state, and it doesn't try and hold on to any reference about anything external to the function, that will never have a stack overflow. Each time it gets to the end of that function, it will just throw away the stack and start again, because there's no information it needs in there. So if I think I did a build all on those. So let's have a couple of terminals. So yeah, using a queue. Debug, so we'll have one of those there. Give me another one, silly program. On the other side. What do I call that? Okay, so if we fire up the subscriber first, there you go, that should be listening there. And then we can just go, whatever this one was called. And I amended it to take a first argument from the command line so we can start pinging through messages there. And off we go. So nothing earth-shattering there. You all know how to do that in C# with EasyNet Queue already. But I just thought it gave a quick overview of kind of how doing very similar things can actually look quite different. Sometimes that helps, and sometimes it doesn't. I'm not claiming that F# is the right tool for every box. I won't do any live coding because I was hoping to give you a bit longer than this, but what I was going to suggest is basically there is a set of what this guy calls F# koans. Basically all they are is a set of unit tests set to run in order from sort of the first one onwards, and it bails out as soon as the first one fails. And our internet connection is speedy. But basically, they're set up to work in Visual Studio 2010. You just clone the repository. It has full instructions. So you just clone the repository, load up the solution, and set F# Coins as startup project. And there's a little fiddly bit about user handle exceptions. And then you run it, and it will give you instructions from there. So we've got about 20 minutes. Do people want to give it a go in pairs at their own machines?
About anything?
Yeah, if you have like a program, an OO program written completely in C#,
yep.
and can you like call a method written in F#? Does it work like that?
Yes. Pretty much everything in F# is exposed in C#. So if you write an F# library, you do have to be careful with some things because they work, but they're a pain in the backside to work with.
Okay.
So, for example, there are relatively nice ways of handling discriminated unions, but when you start doing things like passing tuples around, there is a tuple class in C#, but it's just nasty to work with. So the general recommendation with F# is kind of your library should have a relatively .NET-friendly outer interface.
Oh, okay.
But I've yet to come across anything in F# you can't call from C#. It's just some things get very, very painful, so it's probably not worth it.